Hey, thanks for joining me. Uh, so, okay, building all these cities around the world has obviously used up a lot of good land. Good land attracts people, right? Good land usually involves access to getting stuff from one place to another. But building all this stuff at these places where we gather comes at a steeper price to the planet than you might expect. Now, currently, I am contracted to a concrete company, to Martinez Company LLC here in Kansas City. So I'm digging into the industry as hard as I can. I like to know why things happen the way they do. But really, anyone who pays attention to downstream effects understands that concrete really can be seen as problematic. You've probably seen headlines from time to time, or maybe seen a video or something. The problem with concrete is that it's just too useful. Do you mind if I start with some basics? I had to learn this step by step. One of the big problems is making concrete take sand. This doesn't sound like a bad thing. After all, we literally have tons of it lying around. Like, just go to the desert and grab some. But it turns out that sometimes the stuff you played in as a kid in the backyard just doesn't uh, work for any of this stuff. See, there are different types of sand. All sand is tiny bits of rock that have eroded away over time, usually by wind or water action, and deposited somewhere in large enough quantities that you go, oh, there's a bunch of sand there. It's pretty common in a lot of areas of North America because it accumulated on the glacial ice sheets. Glaciers are basically conveyor belts that dump whatever lands on top of the surface over to the end of the glacier, over and over and over again. That means that a stable glacier that's there for hundreds or thousands of years can build up a lot of stuff in front of it. If there's enough to make a hill, we call that hill a moraine. Eventually, the moraine gets covered in regular dirt as plants like poison ivy, which is a pioneer plant, grow in it. And then little bugs and animals live among the pioneer plants and poop and shed and die. And it all breaks down into topsoil that supports more types of plants and more types of animals. But think about that. When it's deposited, there's a bunch of water involved. That water is important in shaping the grains of sand. Now, other times you have a dry area where sand accumulates. And I'm not going to go into the ins and outs of why this happens in specific places. It all has to do with like geography and air pressure and prevailing winds and all that stuff. But basically, wind blows and it carries like little bits of particles, right? And these particles can hit surfaces. And if they're going fast enough, the particles are big enough, they'll knock off other little particles off of that surface. And then when the when the wind speed drops to the point where it can't support the weight of the particles, they fall down out of the air. They're deposited. Essentially, there's no water involved in the process. And the way the sand is scraped off the parent rock is very aerodynamic, meaning broad and long and sharp compared to the glacial till sand that you find in moraines. And finally, we have the classic sandy beach. A lot of the sand along water actually is along rivers, actually, but oceans can create sand as well. Moving water is the universal solvent. Given time, it will break down just about everything, including rocks, because all of its life as sand is spent in water in this case. It tends to be very rounded rather than long and flat. Think of river rocks. All of this results in sand that, while all of it being sand, actually have very different qualities that matter for our modern purposes. For example, you have special sand used in electronics. They refer to that as silica. This is what the silicon in transistors are made from, but only very specifically shaped and pure sand will do for this. This is rare and valuable, and sources tend to be closely kept trade secrets. Now, if you dig around long enough, you can find information about some sources. That's how I learned about this, was because I just, a few years ago, there's like, oh, did you know about this place? And where, I can't tell you where it is, but it's in the Appalachian Mountains in the Carolinas, and this is where we get our sand for Silicon Valley. And it's hush hush and blah 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 blah. So that's and I'm sure you can find other articles like that around maybe, but this is basically the Rolex of sands. And you could spread this on a beach or make concrete with it, but why would you? Because you need it for something like, maintaining our modern life. What goes into concrete is kind of the middle ground between the stuff in the desert and the stuff we use in electronics. Stuff that has grains that are rounded rather than flat, but not really suitable for silica uh, for for electronics. Now, even if you consider that the sand is fairly common, the construction grade sand is a trade commodity. That means that people want to buy it in bulk. Now, let's take an example. In Hawaii, for example, it's expensive to build, in part because they had to ship the sand in from elsewhere. Oh, you say, but they have beaches. Well, those beaches are rightfully protected. Sand can renew itself, but it can take hundreds of years for it to be eroded away and then redeposited in the right spot on that beach. Concrete is made of cement plus aggregate and some binders like ash and various additives. Concrete is made in a dry powder and then mixed up. That's how you get it from the hardware store. Now, that's about 15% of the volume of concrete. Most of the rest is sand and aggregates. If you want to make a driveway, you need a lot of it. And all that you put into the driveway has to be consistent in how it sets. And you can adjust things for different strengths or how it sets or other characteristics by tossing in various additives. And there can be local requirements for concrete done in this way because of climate or other variables. So for professional jobs, you want a centralized place that can control for these things, but mixed concrete doesn't travel well. It's kind of notorious for getting all hard after a bit. So it has to be centralized, but in a local area. So a place like Hawaii or other island is going to need concrete to build things and make it locally without having a source for raw materials. The problem is that concrete is so useful that the rate of construction, and thus the need for the sand of the right quantity, is causing suppliers to do things that they really shouldn't do. Sometimes, like take sand from public beaches when they can take it, where they can get away with it. This is actually a big problem in a lot of coastal areas because not only will that happen, but people will steal sand from one beach to put on a different beach, often on their own properties. But in other places, riverbeds are dug out to provide good concrete sand, causing rivers to change their flow. This is a big problem in places like Bangladesh, which is a sizable country with a good economy for the area, but it's a country in a major river floodplain that is already ravaged by annual monsoon storms. And it's having even worse erosion problems because of how the Ganges River has been altered through sand extraction to supply building construction. And they make a lot of stuff there, like fast fashion clothing and things like that we use here in this country. And this is actually a major problem facing the world. In 2024, it was estimated that the world uses up to 50 billion metric tons of sand annually. And according to that study, the world could literally run out of construction grade sand by 2050. And the reason is that the world can only generate by natural means about 10 to 15 billion tons a year around the world. And a lot of that is going to, and now that's usable. There's another, maybe 10 billion tons that ends up in the ocean, but that's really hard to use because it's mixed in with a bunch of other sediment and stuff. And for concrete work, you need clean sand, and that's just too often way too much to do. And then even that, you add that to the 10 to 15 and maybe 10, you're still running a deficit of this stuff. Now, one way that this is being addressed by the industry is through manufactured sand. Now, how do you think the sand is made from rocks? Most likely, you said crushing, right? I hope you said crushing because that's the easiest thing. I normally think of sand based on how they're formed, but that's because of my, what I learned in college and stuff. But right now, I'm switching to the actual trade definitions of sand, particularly according to ASTM codes. Now, ASTM doesn't officially stand for anything right now, but it used to be the American Society for Testing and Materials. These codes are maintained by another organization, ANSI, with the names for which I escapes me out at the moment. But they just call me ASTM, and it doesn't officially stand for the American Society for Testing and Materials these days. Apparently, I don't understand how you can say, "Oh, this thing that used to stand for something no longer officially stands for something." You know, the world would be so much better if things actually stood for things. If people stood for things too. That would be nice. That would be really nice. Anyway, sand is separated by ASTM into three size classifications: fine sand, moderately coarse sand, and coarse sand. There are also 18 other types based on other factors, such as apparent rock, like coral, or where we find it, such as continental. But ASTM is what rules the construction industry. So we need to crush the rock to specific size particles. And you know the grain sizes because you can put them through meshes. And I have another video coming out. It's going to reference a mesh that is number 350. The higher the number, the smaller the particles. Fine sand is mostly used for plastering, while moderately coarse sand is used in mortar and masonry works. Coarse sand is used in concrete, and it passes through a number 4 mesh. How big do you think sand can be? 4.76 millimeters in diameter. That's like, that's not grain. That's pebble size. That is considered sand by the industry, and that is larger than I remember encountering as a kid in my sandbox. I was rather surprised by that one. So, what does sand do in concrete? It's an aggregate. Basic concrete is made of limestone and clay, which is the cement, water, and aggregates. The sand and concrete actually has a range of grain sizes. This is not all like this because they just put everything through the mesh, and if it passes through the mesh, it can go into concrete. Anything bigger than that can't. So it's going to have moderately coarse and fine sand in it as well. The limestone and clay become a kind of gel between the aggregate, the sand and pebbles. It's a slurry. When all this is put in place, it's all a slurry. So you have to pour it into something to shape it. And you can do that like in a factory, and then it's called precast. Or it can be done in place, which is what the company that I work for, that's what we do. Then there's this long process that can last for decades. It's drying. In fact, huge blocks of concrete may take a century or more to dry. They say that the blocks in the Grand Coulee Dam still continue to dry today. Now, when I say drying, this is not evaporation. Okay, this isn't like the water vanishing into the air. This drying is a chemical process. It binds with the stuff in there. And this binding releases energy. It's released constantly, but the amount of energy lowers over time because the drying rate decreases over time. Drying concrete can reach 135 degrees. That's a lot of heat being generated. This chemical process is called hydration because basically the water binds over time with the cement. So instead of being a slurry, it binds with the molecules, which strengthens it. And it's chemistry, okay? Chemistry can be weird. You add liquid to this, and it makes to powder, and it can make it like really hard and structural. This is why when people say there's a difference between magic and science, I'm just like, it just depends on your level of knowledge and understanding of it. Because this sounds magic, like it sounds like magic to me. Now you can't use all the sand out there. the issue with this desert sand is that it's really flat, like a pancake. Pancakes are flat. Pancakes don't roll very well. I mean, you could say, oh, but if you freeze them, put it on the end, then again, but no, we're just talking like, as they're sitting there on the plate, they're not going to roll. Make pancake balls, however, and they roll just fine. Same thing with sand in a concrete slurry. Flat sand is not going to pour very well at all, whereas rounded sand will. The kinds of rock used to make artificial sand break into little clumps rather than, say, flat leaves like shale would. It has to be silica based rock, which are fairly abundant and the sand has to be free from impurities that would either interfere with hydration or result in cracking. Now, is artificial sand going to solve all of this problem? And I would say probably not. And the reason why I'd say probably not is according to a 2012 study in India, up to 60% of the sand can be replaced with crushed rock. Others say 70 to 100% in some mixtures. Now, those are more recent numbers because research is ongoing. So there will be a demand for natural sand, but remember those additives I mentioned earlier. Maybe playing around with them might allow this number to go up higher in other use cases where they haven't gone up like that. This is an example of why recycling concrete is so important. We took the sand out of the environment already. We should reuse it as much as we can. That sand we don't have to transport, possibly from somewhere else. That's shorter logistics chains, and that's good for the consumer. That's better for the environment right there, even if we aren't talking sand shortages. When we place less stress on the system, everyone benefits. Now, on a geopolitical level, countries that continue to build but don't use manufactured sand are going to run into greater problems over time with erosion and other issues. Those that recycle concrete are more likely to not hit a wall, so this should be something used everywhere possible. But we can tell that it is not being used because if it wasn't, we wouldn't be using 50 billion tons of sand from the environment. And those numbers come from 2024, not 2012 when they were just like experimenting with how to use, can you use crushed rock instead of natural sand? And that is really where the issue comes from, is that there are so many places where they don't use crushed rock. And sometimes it might just be that the rock isn't readily available, may not be the right kind of rock, whatever. But the more that we use here, where we're pulling up old stuff and the more that we use here, the more, well, we're basically increasing the supply ultimately. And hopefully that 50 billion tons of sand a year that we extract from the environment drops. And because those numbers don't include the stuff that we crush up like this. And that's one of the things that we're doing here at Martinez Company, is we're actively expanding our operation to do this stuff because it's important, because and I'm really excited to be a part of this, because this is something that my whole life it's like, what can I do to do something better? How can I make a positive impact in the world? This is something where maybe it's not like going to solve the sand problem, but maybe we can. And so it's important for new places to step up and fill gaps where they can. That's where the opportunity is, and not for business development. And if you follow my personal channel, you know that I'm big into business development. I'm big into you know economic development in general. And this is just another way that I can contribute something positive. And I'm really proud of that. Anyway, thanks for watching. I appreciate it as always. This is an honor and a privilege to be able to bring you this information. And I hope you have a wonderful rest of your day.